Welcome back. This is Joel, and we are continuing from where we left off. Right, in the previous video, we talked about why do we need ACI, what are the various hardware components. Right, we talked about the various switches which go down into my leaf layer, my spine layer, and we talked about the APIC controller. Right, in this video, we will get a little more deeper into ACI, and to do that, I kind of have opened up here the API GUI dashboard, the APIC GUI dashboard, and I've actually, I really don't have a lab set up right now with me, so I'm kind of like using the sandbox APIC, right? So you can see here, this is nothing but the sandbox, DevNet sandbox, right? So you can, you guys can go down to DevNet sandbox as well, and search for the APIC or search for ACI, and you'll find there is always going to be one sandbox which is always turned on, right? 24/7, it's always on. You can log into it and you can play around with it. You can get to know ACI more better, right? Especially for folks who don't have a lab of their own. This is a good way to learn, right? Cool. So I've just opened this up here because I kind of want to take you guys through the GUI a little bit for a couple of minutes, because this is really going to help with our discussion today, right? So what we have here is literally the APIC, once you install the APIC cluster, you bring it up, you'll have to do a little bit of, while installing the APIC, right, first time, you'll have to do a little bit of configuration, like you'll have to give the management IP address, and you'll have to probably provide, I think, maybe the multicast range and bunch of things. There are a couple of small things, right, when you install it for the first time. But then once you install it, once you bring it up, this is literally the default dashboard which you get, right? And I think I'm running, these guys are running probably something around 4.x if I'm not wrong, right? And the latest ACI is running 5.x, so you can check that out as well. Now coming back here, let's not divert too much. So coming down here, what do we see? We see this is a system dashboard, not something which is very relevant to us. This literally gives you the health of the whole ACI fabric, right? It gives you the health of the individual switches, it gives the health of the whole fabric, the tenants, and so on. So they have like pretty cool algorithms running in the backend, which is able to give us information around how our network is performing, how our applications are performing, and so on, right? Not something very relevant to us right now. So let's get down to the next dashboard, which is the tenants. Now in this tenants, you have to actually get on to one particular tenant, right? So otherwise tenant is nothing but, again, we'll talk about tenants when we talk about the logical models of ACI, right? But just to give you a glimpse, tenant is literally nothing but one instance of your, or actually VRF is actually one instance of your data center, but tenant is kind of like a container, right? Which is made in, which is created in ACI to kind of separate one user's resources from other users, right? Because we talk about multi-tenant architecture, so you really need to have kind of like a boundary which separates my resources, my data center resources from yours, right? So tenant is for that. But so you really need to get down into any of this tenant to understand what really goes in. So you can click on any of the tenant and it opens up and you see a bunch of things here, right? So I've been talking about policy-based architecture, right, since my first video. So, but there's always this question, right? At the end of the day, what are the various types of policies which are there in ACI, right? Now, I always kind of forget some of them, right? So that, you probably will not find this in any official documentation, but I like to remember it this way. So let me show you those. So if you go down to any of this tenant, right, like there's a very funny name for a tenant. Someone who is using the sandbox probably has created one. Anyway, so but when you go down to the tenant, these are some of the things which you see, right? Now let's since you guys, or since in this video series we have not yet introduced ACI completely, right, all the components and so on, so let's try to map this to our traditional data center. So when you talk about traditional data centers, what do you have? You have your applications, right? And that's nothing but what you see over here, right? So grab a pen, right? The applications are here, and the security policies which are needed for these applications to run, right, those are over here. So normally I kind of like to bundle these up, and I like to call this as the these are obviously the tenant related policies, because we are inside the tenant dashboard, right? So they are literally nothing but, I like to call this as the tenant security policies, right? So this is one kind of policy which you see a lot, in ACI, right? Tenant security. So you go down to the tenants and you create your applications and you define the security policies for those applications. The second kind of policies which you see here is this one, the networking side, right? So these ones I like to call this as the tenant networking policies, right? So these are two important policies which you will deal with on a day-to-day basis if you are working with ACI, right? Because you will have users coming in and asking you to deploy their applications. You'll have to define some kind of security, you'll have to define some application profiles, you'll have to define some contracts, and then the networking side of it is also very important, because while you're in a tenant, you really need to define what are the IP pools, right? Each of the and then you'll have to define VRFs, right? If you want to kind of have multi instance kind of architecture, right? Inside a tenant, you can have like multiple VRFs and so on. So we'll talk again, like I said, in the logical models when we talk about all these guys, but these are two important set of policies which you come across on the tenant dashboard, right? Cool. Moving forward, so other one is your fabric, right? So when you go down to the fabric, you'll probably find two of these important policies, which are, one is we are right now on which one? We are on the inventory page. So let's go to the fabric policies. So the fabric policies are mainly nothing but the policies which kind of like dictate, the underlay network of ACI, right? So these are the ones, right? So these guys, right? The underlay, when I say underlay, it's basically nothing but you have the spine and you have the leaves, right? And you basically have some kind of underlay between these guys, right? Over here, so you have like your ISIS, right? You have your MPPGP, right? And so on. So for all of that, if you want to change this, right? So this is literally called as a fabric, and the policies which dictate this are basically over here. Cool. The last one is basically your access policies. So let's go down there. So the access policies, this is, if I have to put it in one single word or one single sentence, my bad, these are the policies which dictate how the external devices are going to come and connect to your ACI, right? I mean, at the end of the day, ACI is nothing but giving you the networking part, but then you still need your servers, you still need your VMs which are there on your servers, you need your clients which have to come and connect to your ACI, right? So these policies dictate how you are going to connect those devices to your ACI. Simple example would be, let's say you have a server connecting up to your leaf switch, right? And you want to enable CDP on that interface, right? You do that over here, right? So that is literally the final part, and this is your access. Okay, my bad. So that's your access policies, right? So we talked about 4 important policies. Just to recollect, we talked about 2 tenant policies. One is the security tenant, and the other one is your tenant networking policies. And then we talked about 2 important policies here: fabric policy and access policy. So these are the 4 policies, and these are the whole 4 policies which you will ever come across in ACI, right? Now, before we get into how to configure this, right, we really need to understand the constructs, because these policies are applied on certain constructs in ACI, and you really need to understand the significance of these constructs before we jump into the policies. Right? So let's get to that. Okay. All right. So when we talk about constructs, right, it's very easier if you divide all these constructs which are there in ACI into 2 models, right? And the brilliant people at Cisco have done that. So there is like a physical model, and then there is what we call as the logical model, right? So when you talk about physical model, it involves all the physical things like, interfaces, the switches, the policies which go on them, the VLANs, and everything which you can really feel and you can configure, you can literally physically touch, right? So those are all your physical model constructs, and in this video we'll mainly talk about that. We'll probably talk about the logical ones in the coming videos. All right, so while we discuss the physical model, let's actually pick a small example here to make this easier, right? So I'm gonna have a spine, let's say I'm gonna call this 201, right? You basically have to give a identifier when you bring up the fabric, right? So let's call this spine as, say, 202. This one is gonna be, say, the leaf 101, and the last guy, say, the leaf 102. Remember, your spines are connected to the leaves this way. All right, that looks good. So, and let's also probably go ahead and put in a simple, I don't know, maybe like a server here, right? So we've got a server here, and that's connected probably via a VPC, dual home to both the leaves, right? Cool. So that's a simple example, right? So this is literally how, in a ACI, in a data center which is running ACI, this is literally how you would be connecting your servers. You'll be connecting the downstream devices onto the leaves. Okay, so let's now talk about the construct. So if you were to do this manually, what would you do, right? The first thing which I can think of is, right, along these links I would need some kind of VLANs, right? So let's start with that. Let's write down that, right? So if we need the VLAN pools, so that's a very important construct in ACI, right? So remember, whenever you probably would have used this command 100 times already, right? And so it's basically nothing but switch port, something like switch port trunk allowed VLAN 10 to 20, right? I think most of us network engineers would have used this command quite a lot of number of times, right? Maybe in an enterprise network or in a data center, right? So the VLAN pool construct basically does this, right? So in ACI, you basically go and create these VLAN pools. Why? Because at the end of the day, you really don't want to go to each of the switches and, manually configure this particular command, right? Because in a traditional data center, if I have to, allow VLANs on a particular interface, I have to basically put in this command. Now imagine if I have like hundreds of leaves, that's really not going to scale, right? So ACI basically automates this process. Now basically this particular command is the outcome of defining the VLAN pools, right? So now there are two different ways of defining the VLAN pools. What are the two different ways? One is your static way, right? And the other one is your dynamic, right? The static is basically you blindly going and, saying, look, I want to allow, say, VLAN 10 on this particular port, right? So you know for sure that is the VLAN number, right? Maybe the server is already tagging, the traffic, right? Maybe the server is tagging the traffic with multiple VLANs, and you want to capture the traffic coming in, probably VLAN 10 as one of your data traffic or something. So if you want to do that static way, go ahead, do that. So that's one way of defining. The other way is via the dynamic way of defining, right? So the dynamic VLAN pool is also a very interesting, it's a bit of an advanced topic, but let me try to break it down in a simple way, right? So let's pick the same example, or let's actually use a magnifier here and try to look at this. So let's say very similar scenario, right? What I'm going to do now is I'm going to take that server which is there, right, at the below, right? So I'm going to run some VMware here, right? So instead of running a bare metal server, let's say I'm running VMware, which is ESXi, right? So what happens in ESXi is normally you have a switch in itself, right? And this is what we call as the vSwitch. On one side of the vSwitch, you have your VMs, right? You have your VM1, probably there's another VM2 here, right? You have VMs. And on the other side, what happens? So you have the leaf here, right? This is one of the leaves, say leaf, I don't know, maybe 101. One of the leaf is present here. So what happens is from the ESXi host, right, you have what they call as the VM NIC over here, right? So the VM NIC is here, and the VM NIC on the other side is connecting to the vSwitch, which is the uplinks. So this is literally how a VMware kind of an infrastructure connects up to the ACI, or actually this particular switch need not be an ACI switch, any data center switch. So this is literally how the connections happen. Now coming back to our discussion, the dynamic VLAN pools, where do you actually use these guys, right? This is literally used in what we call as the VMM integration, right? So VMM integration is basically a cool feature in ACI, right? I think I kind of forgot to mention the epic over here. There will be an epic, right? So VMM integration is a very cool feature in ACI, where using this epic, right, I can literally provision the VMware side of the network as well, or basically I can provision this vSwitch, right, or I can provision the port groups over here, right. Port groups are nothing but VMware's version of, you can think of VMware basically grouping a bunch of ports, right, so that you can put some policies, you can define some VLANs over there and stuff. So now I think I've kind of covered this in the previous video as well. The whole idea of EPIC is to become like the sole controller to control your whole network. You really don't want to have some maybe like a vCenter over here, or you don't want to kind of jump into another dashboard to manage your VMware, right? Rather, you stick to your EPIC, and from here you should be able to push policies onto the VMware side of your data center as well, right? So dynamic VLAN pools are basically used where you can kind of define sitting on EPIC, you can define that, look, the traffic coming from here, right, I wanna kind of have my VMs probably VLAN number ranging from 100 to 200, right? So the EPIC will now provision these VMs, right, in the VMware via the APIs. Obviously the EPIC is going to talk to the VMware using the APIs, so you will have to put in all the credentials of your vSwitch and the VMware vCenter and everything on the EPIC, and it will log into the vCenter, right, technically, and it is going to provision all the port groups, it's going to provision the vSwitch and the distributed switch or standard switch, whatnot, and the VLAN numbers are also going to be provisioned. So that's basically the use case of your dynamic VLAN pool. So that's basically where you use it, right? So it's probably something which we'll again cover later. The VMware integration is a vast topic, but I just wanted to give you a glimpse of where you actually use this one. Cool. All right, so what we have done right now, so we have just on this particular interface we have gone and we have either opted for like static ports, right, in case of like bare metal servers, or if I'm doing something like if I'm doing VMM integration where I'm trying to manage my VMware or virtualization infra virtualization footprint using my EPIC, then I would probably use something like dynamic VLAN pools. Second construct, right? So the second construct, let's see, what is the next question? When you are connecting something here, the next question is how are these servers getting connected to the to the leaves, right? So that's where the construct called domain comes into picture, right? So your devices could be connected physically, right? So basically, literally, you take a cable or you take you basically literally directly physically connect your server to the leaf. So that's a physical domain, right? So literally, domain basically stands for how your external devices are connecting up to your ACI, right? And there could be another approach which is your virtual, right? So that is where going back to the previous use case, right? If I'm kind of provisioning this to be a ESXi, then you're going to have a lot of VMs here, right? So how are these VMs getting connected into my ACI? That is called as a virtual domain, right? So that's a very good example. Basically, whatever I told earlier, right, just before this, the VMM integration is a very good example for the virtual domain, right? Then you have two other interesting options, which is called external bridged, right? And you're gonna have your external routed. So these two are examples where you want to extend or connect your ACI to some kind of a legacy network. So in your legacy network, you probably might have a switch and you want to connect it via L2, or you might have a router and you want to connect it via L3. So those both are your external bridged and router. And we'll talk about this more in the later sections, but I just wanted to, add that as well over here, right? So those are like 4 different ways, and that's basically how do you connect to the ACI. That's basically defined by the domains. Sweet, I think that's good. Next, what do we do next? So we are done with the VLAN pools, we are done with the domains. Now let's actually come from the top, right? So interfaces, right? Interfaces are very important. So what do we have here right now? So we have put in the VLANs, we have decided, we have told ACI how the server is connected. Then the next is probably I might want to enable, say, CDP, right? I might want to enable CDP on this particular interface, right? Technically, in a normal traditional network, I would go under this interface and I would enable CDP, right? But in ACI, how do you do that, right? So you do it using policies, and the very specific policy over here is called as interface policies, right? Let me just reduce the size of this, give me a second. All right, so interface policies, right? So let's look at what this interface policies does. So let's take an example again, right? It's the same thing. Maybe it's CDP or maybe it's something else, right? For example, let's say what you would do in a traditional network is you do interface Ethernet, say 1/1, right? And you would say CDP enable, right? Something like this, right? You would enable the CDP under it, right? But you might not just have CDP, you might have a bunch of things. You might want to change the speed, right, under that interface. You might want to enable, I don't know, maybe storm control, right? You want to enable something related to STP. So there are going to be a lot of such things you want to do under a particular interface, right? So again, ACI gives you this amazing feature where you can define all these policies, right, individually. And why I mean individually is because you can reuse them, right? So I can create a separate policy only for CDP. I can create another separate policy for speed and storm and STP. And the reason for creating the separate policies, then I can reuse them for different interfaces, right? I can reuse them for probably somewhere else, maybe on a different leaf and so on. So that's really cool about ACI. Whatever you create here, it is completely reusable. So these are all modular policies, right? So that's your interface policies. All right. So we are done with that. So we have just created policies now, right? They are still not applied on the interface. We have just created the individual policies. So what do you do next? So the next is we again go one step, after this, after creating interface policies, we go to interface policy groups, right? So it's called IPG, interface policy and groups. Right, so this is basically called IPG, very common thing which you come across, in ACI. Very you hear this very often, right? If you're managing ACI, this is something which you hear very often, right? Cool. So IPG. So IPG, what does IPG do? Now again, going back to the same thing, right? So in IPG, what we do is we kind of all the interface policies which we have created individually. In IPG, we come and group them together. Now, when you're creating IPG, we kind of have different options here as well. You can create an IPG for an access port. You can create it for a port channel, right? And you have a separate IPC for virtual port channel as well, VPC as well. Okay? Right? So, access, what are these three options, right? Pretty straightforward. I mean, whatever we have here, we would obviously go for what we call as the VPC policy group, right? Because we literally have a VPC which is connecting our server up. But what if you had something like maybe like a port channel, which means the leaf is here and then you have the server here and it is connected via a single port channel, right? In that case, you would basically create an interface policy group, right, for the port channel, right? And the access, again, pretty straightforward. What if you had the leaf and you had the server here connected, right, via a single interface, right? Now this interface, this might be a little kind of like misnomer here, but even though if this port was a trunk port, right, still you would go with this option because there is no other option. You either have port channel, virtual port channel, or access. So if you're running an access interface or a trunk interface, right, you would basically go for the access option, right? So that's all about creating, your interface policy group. Now, all of these are like, I'm trying to give you all the theoretical constructs, but we'll probably be doing a lab later in the series where I will obviously be showing you all these various options live as well, right? So that's about the interface policy group, right? Next, so what we have done, so let's let me try to reduce the size a bit again. Okay, so we've got the interface policy group done, right? So so we have created the individual policies, like for example, we have created CDP policy, maybe LLDP policy and all of that. Then we have kind of like bundled them together, right? In our case, we have bundled them together probably for a VPC port group, but it could be anything. It could be even for a access port or whatever. So we have bundled them inside what we call as the IPG, right? So we have done that, but still, right, we have still not applied it to any interface yet, right? We have just bundled them, right? Just keep a track of the progress. So we have just bundled them. So what is the next step? The next step is to go with what we call as the interface profile, right? So all these words might seem a little similar, so just keep a note of this. This is interface policy, this is interface policy group, and this is interface profile. So that's the difference, right? Cool. So in interface profile, what do we do, right? So in the interface profile, right, it's nothing, it's actually pretty simple. What we do is we take this IPG what we have created and we attach it to a generic port, right? To any generic ports. It could be, I mean, if it is port channel, probably it might be 2 ports, right? Or even if it's like a single access trunk link, you might want to configure the same thing on multiple ports of the same leaf switch, right? So in that case, you can simply, use a generic port like you would do with the CLI, right? You can say Ethernet, 1/1 to say 4, right? This is how you would it's a generic port range, right? It could be single port, it could be multiple ports, right? So this is how you're basically defining your interface profile, right? We define a generic. So always remember, interface profile is always related to generic, right? So it's still, we have still, not applied it to the correct leaf yet. We have defined these policies, we have bundled all the policies together in IPG, right? And then the IPG we have taken and we have applied it on a generic interface, right? But we have not told ACI yet on which leaf do we want this to be applied, right? And you guessed it right, the next option is actually going to do that for us. What is the next option? Which is the next construct, which is called as the switch profile, right? So the switch profile, this is where we say, look, Ethernet 1/4, now go and apply this on, say, I don't know, maybe one of the leaf 101, right? So this is how you do it. So this is the final nail, to the coffin. So you do this whole thing. This is literally like the workflow. I'll show you a mind map which I have created, which is really useful in such scenario. But literally a simple example, this is how you do it. You define your policies, individual policies. Then these are all modular, right? Tomorrow I can create one more IPG, using these policies, right? That's the reason of creating all this in this modular way, right? Or I can use this IPG with a different profile tomorrow, or I can use this profile with a different, switch tomorrow when I come in, right? So basically the reason for breaking the whole configuration into multiple steps is to make it as modular as possible so that I can reuse it, right? But I hope this is understood. So this is literally the flow. There is one more important construct which I have not covered yet, and that is the final part which I want to cover. Yeah, so let me see, did I miss that? Yeah, I think I missed that. Okay, so let me talk about that, right? I also want to talk a little more on the VPC construct here, because it's a slightly different than the rest of the IPGs, but I'll probably save that for the last. So the other important construct which I missed, let me just get this over with. Let me keep this. It's fine. Let's probably erase this. I'm running out of space for some reason. Okay. Cool. The very important construct, the last construct. Now maybe let me show you the mind map now, because that would help to kind of put all the pieces together and explain the need for the last construct, right? So let me. Okay, I think this is good. Cool. So let me grab this. Okay. All right. So different color. Yeah, that's good. So we talked about interface profiles, right? Or actually, let's come from the bottom. We defined the VLAN pools. We defined the domains, right? And we kind of defined the interface profiles. Policies, right? Where we define those individual policies. Then we bundled them using the IPG, right? Then we had the interface profile, which was basically the generic ports, and then we went and applied it, or in switch profiles, we basically literally told ACI on which leaf this particular interface profile is going to be deployed, right? But the important thing which I kind of did not bring out till now was the AAEP. Okay, so attachable endpoints, right? So what is the it's basically called attachable access entity profiles, my bad, right? So attachable access entity profiles, a big mouthful of a name, but normally people just call it as AAEP, right? Now, what is the use of this? The AAEP is the one which is kind of connecting all the dots, right? So you have a flow here going in this direction, right? Which is basically, putting the interface profiles together, and it's basically putting all the interface related configuration onto the switch. And from the bottom, you have all this physical resources, right? Because you have literally the ports, the physical, virtual, the bridged and the routed ports coming in from the domains, right? So this is literally the physical resources coming from here, and these are the interface related policies coming from the top, right? AAEP is kind of like the glue, right, which sticks both of them together, right? So if I have to kind of give an example, so it's kind of like having a one-to-many relationship, right? So maybe let me give a different example, or let me give a real world example here, right? So imagine you have a data center like this, right? The same diagram, right? Say you are running probably a bare metal server here, right? This is a bare metal server, right? And maybe you're running a bare metal server here as well, right? And maybe you're running this is the VMM integration, right? This is literally you have the VMs running on this guy, and you want to have those VMs connect up to your ACI, right? And imagine there's a VM integration here as well, right? So in such a scenario, what you do is, and imagine on these both, right, on your which is those on your bare metal servers, and these both you want to run some certain kind of VLANs, and on your VMM integration, you probably want to run a different set of VLANs. Maybe here you want to run 10 to 20, and you want to run probably, I don't know, maybe on the other guy, probably want to run like 30 to 40, right? So you would probably have different kind of properties, right, for this particular for the bare metals and probably for the VMM, right? So in that case, what you do is you create a different AAEP. So you create one AAEP which will kind of bundle up, or which will kind of put together all the IPGs, right, corresponding to that particular, right, type of workloads, right? Say in this case, you can have maybe in this very example, you can have a AAEP for, say, bare metal, right? This will be a bare metal AAEP, and then you will have one more AAEP for VMM, right? And the use of this is you're basically keeping you're making sure that the VLAN pools and the domains what you have created here for bare metal are restricted to the IPGs of that particular type of workloads, right? And then the resources which are there for VMM, they are attached to only certain specific type of IPGs, right? So you get the point. So in a data center, you're going to have a different kinds of workloads, right? You're going to have bare metal, you're going to have VMM, and a lot of other integrations, like people use OpenStack, Kubernetes, and different workloads are probably going to have different VLAN pools, right? And they're going to have different types of domains as well. So you would want to kind of have or segregate this so that it is easy for the isolation. You make sure that only certain IPGs have access to certain pools, VLAN pools, and so on, right? So AAEP is kind of like the glue which kind of puts together that, right? So that's literally the full mind map of all the physical model constructs which you really need to understand with respect to ACI, right? Now, I told you there is one more thing which I probably missed when we are talking about, so you see the yellow part here, which is the VPC Protection Group. So I think I kind of missed talking a little bit about VPC. So let me go back to that. Let me grab that. Give me a second. Yeah. So VPC, right? I really like talking about VPC because it's a really, really fun topic, right? So let me just refresh your memory about VPC, right? Let's go back, because the rest of the topics like STP, port channel, something which we use day in and day out, but VPC is something which you probably will use only in a data center, and unless if you're probably new to data center, you probably might not know much about VPC, right? Cool. So to start with, let's look at a traditional switch, right? You have a switch 1, you have a switch 2 here, right? People used to use port channel for the longest of time, right? But the problem here is when I put in another port channel to another switch, right? And imagine you have something like this. What happens? There is a loop here, right? And STP kicks in, and STP will go and turn off one of the, imagine this is also a port channel, right? And imagine you have port channel here as well, whatever, right? STP is a cruel guy, right? He's gonna go and turn off one of the port channel completely, right? But I mean, by doing this, obviously you're losing the whole utilization on those links, right? So people, but there's a very interesting attribute of port channel, which is really fun, right? So like for example, the first time when I was reading about port channel, my question was, let's get rid of this. My question was, isn't there a loop here, right? For a layman, it does appear like a loop, right? What if my packet goes on one of the link? Doesn't it come back like this, right? That was my question the first time when I was reading port channel. And that's a very valid question, right? And no, the packet doesn't come back that way. The reason is because it has, the port channel inherently has the loop prevention mechanism, right? So the port channel makes sure that the packet which it receives on its interface, it doesn't send back, right? So port channel has this inherent, capability to prevent loops, right? So some intelligent person thought, why not kind of, extend this, but not between just two switches, but, where you have the port channel between just two switches. How about let's extend this, let's get rid of this one like this, right? Just get rid of that, right? And how about I put another switch here, say, I don't know, S3, right? And I'm going to create a port channel this way, right? So now what is happening is he's using the amazing loop prevention capability of the port channel, right? Because we know that once the packet goes this way, it will not be sent in this direction, because port channel has this inherent capability, right? So we are just trying to exploit that, but now between two different switches, right? Where we have established the port channel between two different switches in this fashion, right? So that was a very interesting idea, right? And what have we done as a result of this, right? As a result of this, we have kind of removed STP out of the equation completely, haven't we? Right? Because when STP looks at this, okay, I think let me just draw a better diagram. I think that's very bad. Let me draw that again. Give me a second. So you've got a switch 1, you've got a switch 2, and I don't know, maybe like a switch 3, right? So you've got a link here, you've got a link here, and there you go, right? And probably you have a link here as well, doesn't matter, right? So, right, if this port channel or whatever this VPC virtual port channel which we created just now, if this wasn't there, there would have been a STP loop. But since we created like this, right, the STP, when it's looking from here, right, from this perspective, when STP is looking at it, it appears as if, these both switches are one single switch, right? So when the switch from here looks upwards, it appears this way, right? And yeah, like this. And STP, when STP looks at this, it appears as if a single port channel is connected between these two switches, and STP knows that port channel by inherent has this loop prevention capability, so it is not going to bother, so it's not going to block any of your links, right? So that's the whole funda behind your virtual port channel, right? And obviously there are a lot of other things, like for example, now if one of the switch goes down, still I will have traffic flowing in because this link will still be up, right? So all of that is like very much going into the VPC in-depth part. But coming back to our context here, there are a couple of things you need to understand about VPC in ACI environment, right? So traditionally when you run VPC, you have couple more other constructs here, right? You have generally a port channel, and people call this as the peer link, right? So the peer link is like a 10 gig or higher bundled, links together, and it basically carries all the control information, right? And sometimes payload as well between the devices, right? And there is also another link, right, which is kind of like a link which is like a L3 link, and that's called as the keep alive link. Again, if you want to understand VPC in detail, probably go for a better, I'm just giving you like a quick refresher here, right? So keep alive link is another link which is always running, right? It's kind of like a backup for the peer link, right? So if the peer link goes down, then say the peer link went down, then the switch 2 will try to use this keep alive link to check if S1 is alive, right? Or S1 will use this link to check if S2 is alive, right? And if it doesn't get, let's say for example S2 realizes that S1 is probably, why we need this is to kind of prevent what we call as the split brain scenario, right? So if the VPC is down, right, we don't really want both the guys to be forwarding, right? So this is kind of like a backup mechanism to tell each other, to tell the peer switch, to check if the peer switch is alive, right? And if that guy is alive, then I'm gonna stop. So I'm gonna stop forwarding so that we don't have the split brain issue, right? Now coming back to ACI, we really have some interesting things here, right? First thing is we really don't have these links between the switches, right? I've told you this before, between the leaves and between the spines we don't have any links going, right? So the leaves are not connected to each other as well as the spines are not connected to each other. So having this is out of the box. This one is not there, right? And the keep alive link, obviously we don't have an explicit, we don't, again like I said, we don't have any connectivity. We don't have any direct link going between the leaves, right? So in ACI, what happens is this peer link and the keep alive link, that is all taken care by the spines, right? Because you see this is leaf 1 and this is leaf 2. They are all connected to the spines at the top, right? So it's connected this way, right? So you're going to have the connectivity, but it's always going to be through the spine. So the peer link and the keep alive is taken care by that guy, right? Now coming back here, that is why if you see my if you see my mind map, there's one extra step which is very important while defining or while working with the VPCs, is that you need to define something called as a VPC Protection Group, right? So that's why you see there's a extra piece. So this workflow works for all the other normal port channel. It works for your normal access interfaces, right? And this one still remains the same even though it is VPC port channel whatever. Only for VPC there is one extra step, right, where along with the interface profiles you have a prerequisite of defining what we call as a VPC Protection Group. And VPC Protection Group is nothing but this is equal to, in a normal VPC configuration you would do something like a VPC domain configuration, right? You would define VPC domain. VPC domain is nothing but telling which are those two switches, right, which are going to be acting as one, right? This is literally VPC, right? So you need to define which are these two switches, right? Let's say switch 1 and 2. So you need to tell ACI which are the two switches which are going to form that VPC peers. So that is the configuration which goes inside the VPC Protection Group. And there are different, again, options here. There is like, I believe one is called as explicit, right? Because in ACI, you're going to have a lot of leaves, right? So ACI gives you kind of the flexibility of defining which of the two leaves can act as peers. You want 1 and 2 to act as peers, great, right? Or you want, probably there's another switch which is 3, you want 1 and 3 to act as peers, you can do that as well. So you have different options like explicit, consecutive, reciprocal, and so on. So you can decide, and based on your requirement, you can define which switches are going to be the VPC peers, right? All right. So I think that's mainly what I wanted to cover, right, in this particular video. And I think we have put together everything which we wanted, right? So this is literally the final conclusion. I mean, someone is going to tell you they're going to, they're going to put in a new server, or they're going to add some, virtual workloads, whatnot, right? And they're asking you to kind of go about configuring it on ACI. So this is literally how you start with it, right? You do it like you do it in a traditional network. You decide what VLANs are going to run on it. You decide what kind of, how are they connecting to the ACI? Is it physical? Is it virtual? Is it L2 out? Is it L3 out? So all of that is decided by the domains. And then you also go about defining your interface policies, your IPGs, then interface profiles, which is, putting these IPGs on the generalized, interface ports. and then finally stitching all of that to the switches, right? So this is, when you're coming to this step, this is where the configurations actually get deployed onto the correct switch, right? Because still here, it's all modular. You're defining your policies, you're defining, bundling the policies together. This is nothing but defining the generalized ports. But this is the place where you actually tell ACI, look, whatever I have done till now, go and put this on leaf 101, right? Or 102, right? So this is what I wanted to show. All right, so that's the physical model, guys. Let's actually have a minute here. Let me just go down to the sandbox, which is here. So let's see if I know the password, right? So I have the sandbox epic on, so probably I can quickly show you where all this configuration you would probably see. So you go down to fabric, right? Again, we will probably be doing a detailed lab on this using dcloud or something later in the series, but I just want to quickly show you so that you don't have, you know, this thing in the back of your head that we have looked at all these things, but where do you find them in epic, right? So yeah, this is literally where you find them. So you see your VLAN pools probably would be here, right? There you go, the VLAN pools, right? And next, what did we learn? We learned about the domains, right? So domains are here at the bottom, right? So these are the domains which we talked about. Physical, bridged, routed. Okay, there is fiber channel for storage, which I probably did not cover much. Then what did we do? The AAEP, right? Where do you find the AAEP? I believe it's here under policies. You go to global, and this is where you find the AAEP, right? So what else did we study? Let me just recollect myself. So yeah, so we talked about AAEP, and then we also talked about your interface profiles on the top, right? So you see on the top here, you've got the interfaces. You can check your spines, leaves, right? So here you go. This is your interface profiles, right? You see the profiles. This is where you define the profiles. So someone has already defined quite a lot of profiles here. Interface profiles, very next part of that is interface policy group, right? This is nothing but you know, you basically bundle those profiles together, right? If I click on one of these guys, probably we'll get to see that. Let's probably maybe go to this one guy. A bit slow, I guess. Yeah, there you go. See, this is nothing but the interface policies which we discussed, and they're all bundled together. So you're basically selecting for this particular IPG, right? What are the policies, right? So you select the policies together, and that's how you make the IPG. And then in the mind map, if you see after the IPG, then comes what? Interface profiles, right? Sorry, I think I made a mistake. Before this, I should have told you about the interface policies and not interface profiles. My bad. So the interface policies are something you find here at the bottom, right? Policies, and there you have the interface prof. You just click on this. Yeah, there you go, right? So you got your interface policies. So this is literally the CDP and LLDP and whatnot, right? All the various protocols which you want to run on the interfaces, you have different. These are all the ones which are supported. So you can go and create your policies under any of these guys, right? So we do interface policies, then we do IPG, right? This one, and after IPG, then we do interface profiles, right? Where you define the port selector, right? Which is the generalized ports, right? You take those IPGs and you put it on generalized ports, right? And once you do that, the final outcome of all of this is your switch profiles. So you go down to the switch on the top, under the leaves or under the spines, anywhere you see, you have the switch profiles, right? So that's where you see, and literally this is all, I mean, if you spend probably a few minutes with the sandbox epic, right, you would probably figure this out all on your own, because all of this is self-explanatory kind of thing, right? This is all pretty, you know, drag and drop or you know, kind of drop down kind of a scenario, right? Now that you know where you can find each of those constructs which we talked about, do come down here, check out some stuff, create your own, you know, constructs, and try to visualize how, you know, this diagram would play out, right? So because, you know, just probably you can take a screenshot of this and kind of use this as a reference whenever you want to look at the physical ACI model, right? Cool. Thanks a lot, guys, for watching, and we'll meet again in the next video. Bye.